Hello and welcome to the Chapter 8 test review, where you are going to need to have some lined paper and a pencil, and I'm going to ask that you write everything that you see on the screen, and this will be collected tomorrow before your Chapter 8 test. The good news is, though, everything that you see on this review will be on the test, and the test will be made up of everything that's on this review. So I'll be using obviously different numbers, different situations, but the concepts are still the same. Let's go ahead and get started. All right, so I know this looks like a long problem, but it's just because it's on your screen. It says John has $50 to spend. He wants to buy a watch for $26 and spend the rest on t-shirts. Each t-shirt costs $6. Write and solve an inequality for the max number of shirts he can buy. So on your test, there will be two lines for this because number one, you're going to need to write an inequality, and number two, you're going to need to solve the inequality. So let's go ahead and start by writing the inequality. Remember, like I told you in class, you want to start by trying to find the total, or whatever it is it's going to be on the side by itself, on that right side. So in this problem, it says that John has $50 to spend. So that's the part that's not going to change at all. So let's go ahead and put the $50 right here. And then we want to, it says, he wants to buy a watch for $26. So again, that $26 is a fixed amount. It's not something that's going to change. It is what it is. The watch is done. He spends $26. We're going to write plus 26 because whatever he's spending on the t-shirts is going to be added to 26. And all of that has to be less than or equal to the $50 that he has. So let's go ahead and look and see if we can find the rest of the information about the t-shirts. So it says, and spend the rest on t-shirts. Each t-shirt costs $6. There are two things I need you to put boxes around, each and 6. That word each is what tells us that it's going to be, that it's most likely going to be the one with the variable, and in this case it is. So I'm going to use the letter S to stand for, S to stand for shirts. And so we're going to say that each shirt is $6. So we're going to take that 6 and we're going to multiply it by S number of shirts. And we're going to add the 26. And then all of that, remember, everything that's on the left-hand side must be less than or equal to the $50 that he brought with us. Does that make sense? Because you have to spend less than the $50. So that's why you have that. Now, this would be the first part of your problem right here. So on the answer line, this is what goes on the first answer line. I'm going to go to the next screen so that I can show you what to do next. All right, so here on the next screen, we have the problem that we just had. 6s plus 26 is less than or equal to 50, and we need to perform our inverse operations so that we can get that s alone. So we look to see where our variable is. The variable is s, and it's on the left-hand side. Then we see what's happening to our variable. Well, remember, you're undoing things. So because we're undoing, we're going to do the order of operation in reverse, which means we have to subtract 26 from both sides first. So let's go ahead and do that and get that out of the way. So that crosses out. And then 50 minus 26 gives us 4 here and 2 here. So now we have 24 here. Now, don't forget, you have to rewrite the problem. Because it's a two-step inequality, you have to first perform the first step, which is what we just did, and then you need to rewrite the problem, which is 6s is still less than or equal to, but now you're going to put 24 in because remember you subtracted the 26 from it. So now on the next line, we're going to go ahead and do the inverse operation. So what's our variable? Our variable is s. How do we get s alone? We need to divide both sides by 6 because remember when you have a letter and a number next to one another, that means to multiply. So to undo multiplication, you're going to divide. So let's go ahead and divide both sides by 6, and then you are left with s all by itself, which is what we need, is less than or equal to 24 divided by 6 is 4. So our final answer here is s is less than or equal to 4, and we want to write that this is shirts. So basically what that means is that he can buy 4 shirts at most and still buy his $26 watch, and all of that will be underneath the $50, or actually it'll be right at $50, which is the equal then sign. So you do need to know how to set up and solve that type of problem. All right, for number 2 in our examples, we're going to see the table here. The instructions will say to write an equation. So this is important because you want to make sure that you note that. So I have written the instructions here which says to write an equation. So I'm going to put a big box around that because equation means two things. Number 1, there's going to be an equal sign, and number 2, there's going to be two sides to it. To represent the function, I'm going to underline that word function. Function means that when you give me the final equation, it's going to be in y equals something x format. Okay, so that means that you need to start with the y equals. So let's go ahead and look and see what we can do here. First, we want to check to see, can we get there with an arithmetic pattern? 1 to 5, well, that's plus 4. 2 to 8, that's not plus 4, that's plus 6. So arithmetic isn't going to work. Then we can look at multiplication. 1 to 5, well, that's multiplied by 5. Now let's look at 2. So 2 times 5 would be 8. I'm sorry, 2 times 5 would be 10. Sorry about that. So you know it's not a geometric. So then our last step is to go ahead and take a look and see if we can find a pattern in the output. So to get from 5 to 8, I have to add 3. To get from 8 to 11, I add 3. To get from 11 to 14, I add 3. So we've found a pattern here. So our pattern here is 3, which means our equation, our function should be y equals 3x something. It's got to be 3x something because when you put in, and here's how you do it, you know it's 3x because of this 3 right here. So now off to the side up here, I'm going to put 3x, and then I'm going to do, okay, 3 times, let's say 3. I'm going to pick this 3 right here. 3 times 3. Well, that would give me 9. But what did I get? I got 11. So that means I need to add 2 more to get to 11. So it's 3x plus 2. So you need to know how to come up with a function, an equation to represent the function when the pattern is adding like that. So now you're going to see problems like this. So you'll have 2 problems that are like this. They're written as word problems, and there's an answer line, which is right here, and then there's a line, a number line, which you're going to graph. It says to write and graph the inequality. Then you'll be given the words. It says Joanne must be at least 18 years old to vote. So let's go ahead and look at it. We know that 18 is the number that we're going to put on our line graph. So 18 is going to go right here. And then we'll fill in 17, 16, 19, and 20. And we know that when we say, we won't think about right now what sign it's going to be, an open or closed dot. We just want to know that that's what's going to go on our graph. So Joanne must be at least 18 years old to vote. So her age must be, and let's put 18 over here. Now that we have both sides set up, there we go. Now that we have both sides set up, we can start to look at what we want our sign to be. So this A has to be what? Does it have to be less than or greater than? Well, the A has to be greater than or equal to 18, because when it says at least, that means she can be 18. It includes 18. So on the line over here, we're going to write A is greater than or equal to 18. Then here we're going to go ahead and do our open dot first, and because it's got this equal sign here on the bottom, remember that line, we're going to go ahead and fill that circle in, and then it's going to be all the numbers that are greater than 18. So we ask ourselves, is 19 greater or is 17 greater? Well, 19 is greater, so then we're going to draw our line going to the right. You need to know how to set those inequalities up, so write the inequality and then also graph them. All right, so on this page you see the problem, and it says which of the numbers 7, 8, or 9 is a solution of x plus 2 is greater than 11. So this is a substitute problem. I would like to see you substitute the work. So we'll start with 7. So we write 7 plus 2 is greater than 11, and then we write 7 plus 2 is, go ahead and go back. 7 plus 2 is 9, is greater than 11. And then we ask ourselves, is 9 greater than 11? Well, it's not. So let's go ahead and put a slash through that because that one doesn't work. Now let's try the next one. 8 is our next one. 8 plus 2 is greater than 11. 8 plus 2 is 10. 10 is greater than 11. All right, so 10 is greater than 11. 10 is not greater than 11, so we're going to go ahead and put a slash through that. You may notice that I went ahead and I had to change the numbers. So it should now say which of the numbers 8, 9, or 10 is a solution of x plus 2 is greater than 11. And that's because, so 7 we don't really need. That's because I realized as we were working through these that we were not going to get to a solution. So let's go ahead and do 9. So 9 plus 2 is greater than 11. And then 9 plus 2 is 11. And here's the thing, 11 is not greater than 11. 11 is 11, so you would have to have an equal sign for that to be a solution. So now let's plug in our last one. Like I said, I just changed that. So it's going to be 10 plus 2 is greater than 11. 10 plus 2 is 12, and 12 is in fact greater than 11. So we would say that the solution would be 10. So our solution, the solution that works is 10. So that's what we would write on our answer line, 10. Make sure that you would not write the 12 right here. You would write the number 10. Sorry if that was a little confusing. I had to change the solutions there, the possible numbers. All right, so for this next set of problems, I'm going to have the information here. You want to make sure you're copying the directions, because this looks a lot like when we were asking you to write the equation that goes that represents the function, but it's not the same thing, because what this one says is find the rule for each function table. So remember, you want to be sure not to have y equals in this, because what you're looking for is just the rule. So let's look and see if we can figure out the rule here. First, we want to look at arithmetic. So 1 to 7, we would add 6. So let's look at 2. Well, if you add 2 plus 6, you get 8, not 14. So now let's look at multiplication. We can get from 1 to 7 by multiplying by 7. So let's look at the next one. 2 times 7 is 14, and 4 times 7 is 28. So our rule, what would go on our answer line, like right here, would be 7x, because x is our input. So don't forget that x is input, y is output. That is all that would go on that line. Not y is equal to 7x, just 7x, because it says find the rule for each function table. For this next set of problems, you're going to have 6 problems that are similar to this one. And so I'm going to do 2 separate examples. One that's just a 1-step and another one that's a 2-step. So for this particular problem, it will say solve each inequality, then graph the solution on a number line. So the first thing you would need to do is solve the inequality. And just a reminder that solving inequalities is just like solving equations, except you have that inequality sign. So we locate the variable. We found it right here. It's x. And now we want to say what's being done to x? Well, x is being multiplied by 2. So to get rid of that, or to undo that, we're going to divide each side by 2. So we're going to show that here, and you need to show it in your work as well. Then you are left with x is greater than or equal to 12. And then you'll just have a number line. So you'll have 2 lines here. The first one, you'll write your x is greater than or equal to 12. So that's what will go on the first line. And then on the second line, you'll have little number lines like this. And you'll put 12 right in the middle, 11, 10, 9, 13, and 14. Like I've shown you here. I can go ahead and erase that end right there. And once you're there, you're just going to go ahead and do either an open or a closed circle. Don't forget it's closed circle because of that line right there. So it's a closed circle. And now you have to ask yourself, x is all the numbers that are greater than or equal to 12. So that means it's got to go to the right, because those are all the numbers that are greater than 12. All right, the next problem we have here is a 2-step inequality. So again, we're going to satisfy or solve our 2-step inequality exactly the way that we did with equations. And remember, we need to undo our addition and subtraction first. So what we look for is what's being done to the variable. So first it's being multiplied by 2, and then you have to subtract the 4. So to go backwards, to undo that, we're going to now add 4 to both sides, because this is minus 4. So we're going to do the inverse or opposite, which is to add 4 to both sides. So that gets rid of that. And now we have 22 plus 4 gives us 26. This is very important here. You need to make sure that you rewrite the problem. So you have 2x is less than 26, because this 26 is what we got right here, and the 2x is what's left over here. So now that you get to this point where you have 2x is less than 26, it's a 1-step inequality again, just like we did on the previous screen. We're going to divide each side by 2, and then we're left with x is less than 13. And again, you would have 2 lines. The first one would be where you would write x is less than 13, and the second one is where you would plot your points. So 13, 12, 11, 14, 15. And then you would do an open circle on 13, because remember, since it doesn't have that line that we're used to seeing there, it does not include 13 as a possible solution. Now x is all the numbers that are less than 13. So that means we need to draw our arrow going to the left, because 12 and 11 are less than 13. I just wanted to throw one of these examples in here, because I know sometimes when you see this algebraically, you panic. So I want to make sure that you've been exposed to it in the recent past. So when you see x divided by 2, remember that's what that bar right there means. It means division. Okay, so when you see that bar, it means divided by. X divided by 2 is less than 6. Since it means divided by, that means to do the inverse or opposite, you're going to multiply each side by 2. Notice when I put my dot up here and when I put my 2 up here, I put the 2 up on top. You can tell it's not in the center right here. That's definitely not where we want it to be. We want it to be up top. And the reason we do is so that we're kind of cued in our brain to cross simplify these 2's out, because that's sort of the whole point of actually multiplying both sides by 2, is so that you can get rid of that divided by 2. So now you're left with just x on this side is less than 12. and then you would obviously write x is less than 12, and then you'd be asked to graph it again. So again, 12, 11, 10, 13, and 14. It would be again an open circle on 12 because there's no equal to sign right there. So it's open circle and it's all the numbers that are less than, so we're going to go back to the left. All right, for this example, you'll be asked to complete the table. It will be set up like this. I want to point out a couple things before we start on it. First of all, you see the input here, but notice you're missing that input in that third bar right there. And notice you're missing obviously the output here and here, but you're given the output of 24. So I just want you to take note of the fact that that's how it's going to show up on your paper. So the first thing that you want to do is start substituting. So the way that we do that is we're going to start by writing 2, and then we'll write, instead of x, we're going to write an 8, which we got from right there, minus 6. And then we say to ourselves, okay, 2 times 8 is 16, minus 6 gives us an output of 10. Okay, now let's look at 10. So we're going to have 2 times, let's go ahead and substitute our 10 right there, minus 6. Now remember, all of that comes from directly up here. We don't change anything except what we have in here for x. So now 2 times 10 is 20, minus 6 gives us 14. So we're going to put that right there. And now comes the tricky part. Now we know that whatever this is, we need to figure out what the input is. So here's what we do. We work backwards. So let me show you how to do that now. We're going to start with 24 over here on the right-hand side because we know that's the output. And we're going to look at 24 being equal to 2x minus 6. Now notice what I did. All I did was I took that function rule, which is right there, the 2x minus 6, and I set it equal to 24, which is what they told me the output was. And now all we're going to need to do is solve for x. So we'll start by adding 6 to each side. And now we have 30 on this side. I'm running out of space, so I'm trying to squish it here a little. And now that we have done that, we've got 2x is equal to 30. So now we're going to divide each side by 2 so that we can solve for x. And we get x is equal to 15. So now we can go ahead and put 15 right here. We know that x is 15 when y is 24. And then we can fill in the rest of our table here. We've got 2 times, so in white I'm going to put 15 minus 6. And then you are complete. All right, so now you see the problem. Susie saved $600 to go to Florida. She will spend $200 on her ticket. Write and solve an inequality to find the maximum amount she can spend the rest of her trip. So I realize you can do that in your head. The numbers on the test are not going to be quite as easy. Regardless, you have to do 2 steps. They're going to be 2 answer lines. So the first answer line will be for your inequality. So let's go ahead and set up that inequality. As I've said before, the easiest thing to do is to locate what number you think is going to be a loan. So the $600 is a definite amount. That's what she saved. That's what we're working towards. That's what we have to work with. And we got that from right there. So it says she saved $600. Now it says she'll spend $200 on her ticket. So let's start looking at the other side. So we're going to put that 200 over there. So now it's going to be the 200 plus whatever amount she can spend, right? That's all the extra money. So everything that's on this left-hand side is going to have to be less than or equal to the 600, right? Because you can't have her go over 600. So what you're basically saying is blah, blah, blah over here has to be less than or equal to 600. I'm going to go ahead and erase the blah, blah, blah line. I just wanted to make sure you understood. So this would be my inequality. I would write this on my first line. 200 plus x is less than or equal to 600. Then my next line is going to be solving that problem. So what I would do is just subtract 200 from each side, like you probably did in your head as soon as you saw the problem, and you are left with x is less than or equal to 400, meaning she can spend $400 for the rest of her trip and still stay on budget for her $600. Now, to prepare you for this last piece that's on the test, I wanted to refer back to a textbook page because that was really probably the best way to have you look over it. So if you refer back to textbook page 607, you'll see the type of problem that I'm talking about. So I'm talking about these problems where you have 3 steps. Let me go ahead and show you on the next slide a close-up version. All right, so on the test, you're going to see a problem that is very similar to this. It's going to have, it looks like 4 different parts. So it'll have where you have to write the equation. Now notice it says equation, which means there should be an equal sign and there should be 2 sides. And then it has you fill in a table, then it has you write a graph, and then it has you analyze the graph. So this is the last problem that will be on your test. Okay, so like I said, we did do this problem in class, but a couple things to note before we get started on it. Number one, the table on your quiz or test rather, whoops, it's a little too dark. Okay, so number one, the table on your test does not have this and does not have this written. So you'll be in charge of writing that in the table. So it'll be a blank table. The table is already set up, but it will be blank. Also, your graph will not have this. So you'll be in charge of labeling the graph there, as well as numbering the increments. So it will just be a blank graph. It will actually say D and P for days and pounds. This one says D and V, so it's very, very similar. But I just wanted to give you a heads up on that because you'll have to fill in the whole table and the whole graph, including each of the things that I've circled here. So let's go ahead and take a look at this. It says an African elephant eats 400 pounds of vegetation each day. So 400 pounds is important. And notice there's that word each again. And that's so that we know that that's going to go with the variable for day. Write an equation to find V, so see that V right there, which is the number of pounds of vegetation an elephant eats in D days. So what we want to first do is start with that equation. So V is going to be by itself because V is in this, V is the total, basically. It's the amount of vegetation that they'll eat after so many days. And it's going to be equal to, remember this is an equation that we're writing, so there needs to be an equal sign. It's going to be equal to, and remember that 400 that we got right here. So see the 400? 400 pounds per day. So it'll be day right here. D. So for example, this would be what I would put on my first line where it says write an equation. So that's where I would put that answer. V equals 400 times D. Because since they eat 400 pounds each day, you know, you want to have the number of days that they eat and so on, and then write the numbers in there. The next thing says to make a table to show the relationship between the number of pounds V an African elephant eats in D days. So the first thing you would need to do is write in the title. So see that number of days D and pounds eaten V. You would need to write that in. Then you will need to fill in the numbers. So for instance, if we were going to do 1, 2, and 3 days, it would look like this. Okay, so once we put in 1, now we have to plug it into our equation, which was right here. So V is equal to 400D, so I should see your original problem. Then we're going to substitute. We've got V is equal to 400 times, and now D, we're going to write in a 1 because we got that 1 from right here. So 400 times 1, so V is going to be equal to 400. So when D is 1, so when we're talking about 1 day, we're talking about 400 pounds. Then we'll do that so on. So it'll be 400 here, it'll be 800 here, and it'll be 1200 here. Okay, so we have to show the substitute and solve for each of those. So that would take care of the making of the table. Then it says to graph the ordered pairs and analyze the graph. So on your test, analyze the graph is a separate question. So the third one will say graph the ordered pairs. So we'll look and we'll go, okay, when X is 100, which in this case it's D. So when D is 100, V is 400. So we'll go to the 1 right here and we'll go up to the 400 right here. So we're going to make a dot. When D is 2, V is 800. And when D is 3, V is 1200. Okay? So that would cover us for the graph. But remember, you have to do the graph sides as well. You have to label both of the sides here, and you have to graph the points in the correct place. All right, and then the last part will say analyze the graph. So for the analyze the graph part, we want to look at the points here that we're looking at on the graph, and we can see that there's a direct relationship. So for every day that we go up by 400. And the reason that is because it's $400 each day. So you would want to say for your explanation that the graph is a line. All right, so right here I've written the explanation. The graph is a line because each day the vegetation increases by 400. So that's how you would analyze the graph. You would talk about the points being on the line, and that's because there is a consistent linear pattern, basically. So again, what you're going to say, though, is the graph is a line because each day the vegetation increases by 400. Okay, and I realized I left one question out, so I wanted to make sure to get that one in there too. Jess needs to buy a dress for $300. She earns $10 per hour babysitting, and her mother gave her $20 for mowing the lawn. So now we're looking at the problem. It says to write and solve an inequality to show the minimum number of hours she needs to babysit to buy the dress. So first we want to identify what the total is, as I've said before. So I can identify that this $300 right here is what I'm trying to get to. So $300 I'm going to put on the right. And then we want to identify anything that we already have to put on the left. Now notice it says that her mom gave her $20 for mowing the lawn. So that's that flat fee or that flat rate. Keep in mind, that's not a per hour thing. That's something she already has. So when she combines her hours of babysitting, let's actually think about that too. So H is going to be the number of hours that she babysits. So off to the side, you just want to kind of define that for yourself. So she babysits for so many number of hours, and she makes $10 per hour. So we got that from right here, $10 per hour, plus she has some money from her mom. So plus that $20 that she has from mowing the lawn. So you have $10 per hour plus the $20 she already has. All of this that needs to be on the left-hand side here, all that needs to be greater than or equal to. So it can be more than that or equal to $300. So this would be your first step, would be writing this on the line. That would be your first answer right there, is coming up with the inequality. Then on the next page, I'll show you how to solve it. Okay, so on this page, we see 10h plus 20 is greater than or equal to 300. From here, we're going to first address this addition or subtraction. In this case, it's addition. So we're going to subtract 20 from both sides. And in your brain, when you think about it, that makes sense. Because if you need to get to 300 and you already have $20, then you're going to take $20 off of that total that you need to work for. So now you have $280 here. So now we're going to rewrite. Don't forget to rewrite that expression. So now we have 10h, because that was left from right there, is greater than or equal to 280. And now to get rid of the 10 that's attached to the h, remember 10h right next to each other means to multiply. So then we're going to have to divide to undo that, because remember you have to do the inverse operation. So then you're left with h is greater than or equal to, cross those out, 28. And so what that means is that she would have to work at least 28 hours babysitting. And actually, we'll just say work at least 28 hours to buy the dress. And that is it. We have covered every type of problem that you will see on the test. Good luck, and I will see you tomorrow. Be sure that you've written everything down that I've written here. I'm going to collect this at the beginning of class, and it will be a graded score for you. Thanks so much for tuning in, and I will see you soon.